So to do all of this stuff in a complex software system means we have to be really productive. And that sounds like a cliche, but we can actually sort of quantify what productivity means and why it actually matters a lot for software engineering. And we'll talk about 4 mechanisms that over the decades have been developed to help software engineers be more productive: conciseness, synthesis, reuse, and cool new tools. But first we ask why productivity matters. For over 50 years, we all had the blessings of Moore's law, which predicted that processors would become roughly 2x as powerful every year and a half. And if you've got that rate of progress, hardware got faster and more powerful really fast, and that meant that it could run more complicated, more powerful software, but the development of that software became the pacing item. So if you're going to develop much more complex software, you need tools and methodologies to help you develop it faster so that you can take advantage of all of that hardware performance. And historically, there's basically 4 main categories of ways that software engineers have done this. Clarity via conciseness is one of them, using less code to do more stuff. Synthesis, having code that writes other code for you. If there's boilerplate code, is there a way that you can sort of write a much higher level of abstraction version and have it spit out the code you really need? Reuse. The holy grail of software is like, if you can put together a project and write 0 lines of code, in some sense, that's a win. Because if you can solve somebody's problem without introducing bugs, and notice my equation there, right? When you write code, you are writing bugs. Let's all admit that that's a fact of life. So the less code you write, the fewer mistakes you're likely to make. And if you can reuse other components that are proven and use them to solve part of your problem, that's a life skill as well. And finally, tools and automation. There are tools of many kinds, but automation is particularly important because whenever you find yourself doing some task in software engineering that has more than like 2 steps in it, you should be asking yourself, can I automate this? And if not, what is preventing me from automating it? So we'll talk about the benefits for each of these things, and we'll give a couple of examples. Clarity via conciseness is one of my favorites. And when you read the book, not if, because I know you all will, you'll see this cute little icon showing a hand, showing a teeny tiny little thing, conciseness. This is about raising the level of abstraction so you can do more functionality basically with fewer words. Very, very high level programming languages are, one of the blessings that we've been given by Moore's law. No one has to write assembly language anymore to a first order. Things like automatic memory management, which is the source of so many security bugs in programs written in lower level languages like C. Languages like Ruby and Python that have reflection and metaprogramming. They let the language ask questions about itself so that you can write code on the fly. So the idea is we can exploit the syntax of these very high level languages to make things more concise. For example, something you might see in a testing framework is you do some operation and then you're trying to assert that some variable is greater than or equal to some other value. Or if you have a language that has a more flexible syntax, you could say something like this: expect A to be greater than 7. And this is a personal thing with me. This is just easy on the eyes. I love code that when you read it, it explains itself. It doesn't even need a comment because the way the code is written tells you immediately what it's going to do. I'm also going to give an example. Suppose I'm calculating a time, and if you sort of think about this line of code for a couple of seconds, you can figure out that what I'm trying to calculate is, assuming time is expressed in seconds, the time that was sort of 2 hours ago. 2 times 60 seconds times 60 minutes. Or, if you're lucky, you can write something like that, which in Ruby, in fact, you can, right? Again, it's not just sort of a neat trick. It's that it reduces the cognitive load that gets between the programmer and their code. Here's another example. This is actually cut and pasted from some horrible, horrible website I visited. I don't remember which one, but this was a piece of JavaScript code. You can see what it's trying to do, but I hope that this makes you cringe. I hope that this makes you say, somebody copy and pasted. I hope it makes you say, a large language model could have written better code than this. Copilot could help me more than this. Or you could write this: if index is between 0 and 4, then substring of that index, otherwise nothing. Right? Again, once you learn to read the idioms, that bottom line is not only shorter, which means fewer mistakes are likely to appear in it, it also essentially explains itself. So those are some examples of clarity via conciseness. When you can make your code shorter without losing functionality, you should look for ways to do that, just like when you're writing a paper. Synthesis, code that writes other code. You'll see this little gear icon in the book where there's examples of code synthesis. And the earliest example that I know about, which was in the 1970s, is there was this code that would run a convolution mask over a graphics image, but depending on what operation needed to be performed, the innermost operation of this like triply nested loop would have to be one of a combination of different Boolean operators. And having a Boolean test in the inner loop was very expensive. So instead, there would be self-modifying code that would rewrite the loop to generate just the version of code that was needed for that particular instance, and then it would run that version. Thankfully, today, we don't really need to use self-modifying code anymore, but there's a lot of common uses of synthesis. We'll certainly see a lot of them in the Rails framework called code generators and templates, where there's some boilerplate code that has to be written to sort of get a piece of the program off the ground, and then you have to fill in and customize it. But the boilerplate parts can now be automatically generated. So we'll see a lot of example of code that writes other code. Reuse, dry it out. You'll see the towel icon for places where the book is calling it examples of don't repeat yourself, which means every piece of knowledge, everything that is part of a code base should only live in one place. And if that needs to be reused in multiple places, then you need some mechanism to do it. So if you find yourself copy-pasting code from file A to file B in the same project, and then you make minor little changes to the version in file B, something is wrong, right? Your Spidey sense should say, there's some commonality here that I need to capture and extract so it can be reused in different ways. So you have to find ways to factor out commonality so they can be reused multiple places. And historically, we already know some of these. That's what a function is, right? A procedure or a function is just a way of capturing some common functionality that can now be called from many different places. Sometimes a group of functions is collected into a library, and that library performs a certain set of tasks with those functions. And now, by importing that library, you get access to all of that. In object-oriented programming, the idea there was that now an object comes with a bunch of behaviors, a class. And that whole set of behaviors can be reused across different applications. We're going to learn about design patterns, which aren't really about reusing code, but it's about reusing a strategy. It's about looking at a problem and saying, a good structure for solving this problem would be as follows, and then essentially applying that structure to the particular code in that example. And this is speculative, but who knows where LLMs are going to take us, but maybe we're going to start reusing prompts. I saw a pretty impressive example of an LLM writing a JavaScript program to, I don't know, animate an American flag or something. Not rocket science to write, but it would have taken me like probably a couple of hours to write it just to get the mechanics right. And it took GPT-4 about 30 seconds. So who knows where that's going to take us. Interesting times that we live in. Okay, that's the third of the 4 ways that we can increase productivity. The last one is automation versus doing things manually. The main reason is not just that it saves time, though, it's that it improves accuracy. If you've ever managed a large project using make and makefiles or using Ant in the Java world or anything like that, basically a program that manages dependencies, figures out automatically which parts of the file have to get updated and which parts don't. It's not just that that's faster than doing it yourself, it's also more accurate in most cases than doing it yourself. So we will see a lot of analogs to this in software as a service, where there are tasks, especially related to things like deployment, maintenance, operations, testing. A lot of those tasks are complex, multi-step tasks with internal dependencies, and automating them is not only a time saver, it makes things foolproof. It means you press a button to redo the task, and there's a whole category of mistakes that you're now not able to make. Any new tool has to sort of justify its own investment. So it always takes time to learn how to use a new tool, but in the long run, if it's worth it because you save much more time, that's what makes a tool valuable. So we will do our best to only introduce you to tools that we think are enormous time savers. But as we said, this is a life skill for software engineering. So embrace the opportunity to learn how to use new tools. I guarantee you're going to see a great many of them in your career. And you'll certainly get lots of chances in this course. There's going to be tools for test writing, tools for user stories, tools for telling you all kinds of ways in which you could improve your code that you probably hadn't even thought about. And then we'll see who's better, you or ChatGPT. And the cute little robot icon, the robot used to have hands, and at some point, the robot lost the hands. But the robot is places where we're indicating this is an opportunity to use a tool to automate this particular task that you would otherwise have to do manually.